It feels like absolute magic, right? You type a few letters into a search bar, hit enter, and boom. Within milliseconds, a fully formed web page just appears on your screen. But behind that single keystroke lies an epic global relay race. I mean, in the fraction of a second it takes you to blink, a massive multi-step micro-journey happens between your device, your local router, undersea fiber optic cables, and servers that might literally be on the exact opposite side of the planet.
So, what exactly happens behind the scenes when you type a URL and press enter? It's actually one of the most famous interview questions in tech, primarily because the answer touches nearly every single layer of modern computing. It is the ultimate test of your holistic systems knowledge. Let's lay out our flight path for this explainer. We'll look at behind the enter key, the core relay race, a real-world example, common internet misconceptions, why this matters, and finally, next up, the OSI model. All right, section 1, the core relay race, from keystroke to pixels.
This beautifully illustrates our entire high-level roadmap. We're going to ground ourselves here before we zoom in and track our glowing packet of data through each specific phase. We start with the URL on the left, move through the network, talk to the server, and end up right back at the browser on the right.
The really crucial point here is that this instantaneous experience is actually a meticulously choreographed 6-step sequence. We go from parsing the input to a DNS lookup, establishing a connection, sending the HTTP request, getting the server response, and finally, rendering the page. So, let's break these down one by one.
Step 1, parsing the input. Before your device even thinks about touching the internet, your browser parses what you just typed. It first asks, okay, is this a search term or a web address? If it's a URL, it breaks it down into its functional parts, like the protocol, HTTP or HTTPS, the domain name, and the specific path. The browser also does a quick security check against its preloaded HSTS list to force a secure HTTPS connection. It wants to make absolutely sure you're routing securely from the very first millisecond.
Now, step 2 is the DNS lookup, and this is where it gets really interesting. Computers don't understand human-friendly names like example.com. They only speak numbers, specifically IP addresses. So your browser has to consult the domain name system, or DNS, which is basically the digital phone book of the internet. It translates that domain name into a precise numerical IP address, so your device knows exactly where to send its request. Once we have that IP address secured, step 3 is establishing the connection. The browser opens a TCP connection to the server using a clever little process called a three-way handshake. The client sends a SYN packet to synchronize, the server replies with a SYN ACK, and the client acknowledges with an ACK. It's essentially a quick digital conversation saying, hey, are you ready to talk? Yes, I'm ready. Awesome, let's talk. And since modern web traffic is secure, this is immediately followed by a TLS handshake to completely encrypt the channel. With that secure tunnel locked in, we hit step 4, the HTTP request. Think of this step as a digital letter being sent through that secure tunnel, politely asking the server to deliver a specific file. The browser sends an HTTP GET request, which includes a request line and a bunch of headers. These headers contain important metadata, like your user agent, which just tells the server if you're browsing on a phone or a desktop so it can format the response perfectly for you. Step 5 is the server response. The web server processes your request and shoots back a response, starting with a status code. We absolutely love a 200 OK, which means success. But you might also see a 300 series for a redirect, a 400 client error, like the infamous 404 not found, or a 500 error if the server itself crashes. Right after that status code comes the actual payload, the raw HTML, CSS, and JavaScript files that make up the website. And that brings us to the final step, step 6, rendering the page. The browser's rendering engine takes all that raw code and goes to work. It parses the HTML to build a structure, applies the CSS for the styling, and executes the JavaScript for interactivity. It literally calculates the exact coordinates of every single element and paints the page onto your screen, pixel by pixel. Let's move on to section 2, a real-world example, connecting to wikipedia.org. Let's ground this theory in reality. When you type wikipedia.org into your browser, your phone or computer ultimately converts it to a very specific numerical IP address. It might translate to something like 103.102.166.224. That is the exact destination your data packets are trying to reach. And here is the mind-blowing part. A secure tunnel is locked down across oceans via undersea fiber optic cables. The server packages the text of the article you want and flies it all the way back to your device, all in under 100 milliseconds. This exact choreography happens billions of times a day for every website visit from every device on Earth. Section 3. Common Internet Misconceptions. Let's separate myth from fact.
First up, the myth that websites are sent directly from a company's main headquarters. The fact is, your data isn't flying from a central server on the other side of the globe every single time. Instead, sites use global content delivery networks, or CDNs. This means you're actually pulling data from a cloned server located maybe just a few miles away from you, which massively speeds things up.
Second, there's a myth that once a web page loads, well, nothing else is happening. It's just sitting there. But the truth? Modern web pages are living software. Background scripts are constantly running, fetching new data, and seamlessly updating the page without you ever needing to hit the refresh button. Finally, there's the myth that the elaborate DNS phonebook lookup happens every single time you visit a site. In reality, that process is skipped most of the time, thanks to incredibly aggressive caching. Your browser, your OS, your router, they all cache data. So if you visited a site recently, your computer already remembers the IP address and just skips the lookup entirely. Section 4, Why This Knowledge Matters. The foundation of modern computing.
Look, this journey isn't just fun tech trivia, it's foundational. For developers, understanding this flow is the absolute key to optimizing application speed, leveraging caching, and ensuring top-tier security via HTTPS. And for job seekers, this is the ultimate interview gold standard because it proves you understand the internet holistically, rather than just knowing the single layer of code you might write day to day.
Section 5. Next up, the OSI model. Mapping the hidden machinery.
This explainer is just the beginning of our new mini-series diving into the hidden machinery of the internet. In our next explainer, we'll introduce the OSI model, the formal 7-layer map of everything we just walked through today.
So I want to leave you with this final thought. Can you map the global journey of a single URL request that we just discussed directly to the 7 layers of the OSI model? Think about how today's relay race fits into that structure and follow along so you don't miss the answer. Thank you for watching the Tech Canvas. Complex ideas, clear pictures. Follow for more.